So let's go over Unit 3s. That way I can have these for anybody who needs them at home. One of the things on number 28 that I wanted to show you is that when I graphed apples, $1.50 each, and I wrote an equation, I wrote y equals $1.50 x, because if I buy one apple, it's a 1 times $1.50. If I buy 2 apples, it's 2 times $1.50, and so on. But when I went to graph it, I graphed it discrete. Why did I graph it discrete? Because you're not going to buy 1.5 apples. If you do, I'll be surprised. If you have a half-eaten apple, you're not going to do that. Most people don't. But how did I do it? 1 apple, $1.50. 2 apples, $3. 3 apples, $4.50, and so on. That's why we use discrete graphs when we talk about counting by whole numbers. There's multiple answers here for 29. You could do 4s plus 6 equals 134, or you could do 134 subtracted 6 or subtracted by 6 and then divide it by 4. That would also be equal to s. Some equations for you. And this one I saw again. The graph of f of x is shown to determine the ordered pair that is the solution to the equation represented by f of x equals 0. Where does the function equal 0? Where is the y value equal to 0? And the x value is -3 when the y value is 0. That's what it's asking for. It's asking for this point right here. That's the hard one. That's the one that you have to get used to the notation for it. And the answer is -3, 0. If I go over to to number 32, it's another discrete graph. A lot of people wrote this equation, 5b plus 1s equals 31. $5 per book plus $1 per song equals a total of $31. And I used x and I used y, and I put it in y equals mx plus b form. And then I made another discrete graph, because I'm not going to buy 1.5 books or 1.2 books. I'm not going to buy this stuff in between. So I made my x-axis books down here just like this. And I did 1, 2, 3, 4, 5, 6. And then if I buy 0 books, I have $31 for songs. And if I have 1 book, I have $26 for songs. I can get 26 songs and so on. And it makes this decreasing graph, and it's discrete as well. The purchase combinations, I just wrote a table and I said, well, if I buy 0 books, I can get 31 songs. If I buy 1 book, I get 26. And I went all the way from 0 all the way to 6. 6 books, 1 song. And I didn't have enough room to do the full table, so I made a second table right there. You had to make choices whether things were true or false about this graph. And just so you are aware, it went true, false, true, 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 false. Did any of you have any questions on those? I'm hoping you remember slope-intercept form. What the slope is the m. I thought that was easy. I thought the 1 was easy. Here's your y-intercept. You go up 1 over 4, and you make your line through the 2 dots. Number 35, on the other hand, some of you have forgotten. As I was walking around last class, I saw some of you forgot the form of this one. So I'm going to write it down. Y minus y1 equals m times x minus x1. This is called point slope formula. And when we wrote down opposite, opposite. I need to say that because some of you are going to forget. The opposite of what is next to the x, the opposite of what's next to the y, is where your x coordinate is and where your y coordinate is. So when I look at this and I see this x plus 1, the x-coordinate is the opposite of positive 1. The x-coordinate is negative 1. And over here, the opposite of negative 2 is positive 2. It goes through negative 1, positive 2. And on my graph, that's to the left 1 and up 2. I know it goes through this point. And I know what the slope is. It's down 3 over 1. Down 3 over 1. I did not even turn this into slope-intercept form, and I know some of you did. And that's okay. If you want to turn it to slope-intercept form, you can, but there will be some questions that say, what's the slope? And you should know that's the slope. Name a point that it goes through. Opposite of the x, opposite of the y. That's what it goes through. Very little work to do if you know the equation. The last page of Unit 3 was actually taking that equation and then turning it into slope-intercept form. So if you did it the other way, you're kind of like, well, now it's asking you to distribute and to move the 2 over, and you get the same equation that has the same slope, and it has a y-intercept of negative 1. It's the same graph is what I mean when you finally get there. I think there's a typo on this. It says change it to slope and y-intercept form. I believe it should say to slope-intercept form, and not, I don't know why they have that in there. That's a typo. You're supposed to realize that these two graphs should be the same on 35 and 36. And then intercepts for 37. The way that I taught how to do intercepts is that we had x's and y's, and we did things like this, where there was a 0 and a 0. You had to plug in a 0 in for an x and figure out what was y when x was 0. And this would be a y-intercept. You could plug in 0 in for y and then figure out what x had to be. And that's called the x-intercept. Here's my y-intercept. Crosses the y-axis. Here's my x-intercept. It crosses the x-axis. And I can graph the 2 points based off of those two intercepts. The last thing on 38 was changing this equation into slope-intercept form by subtracting 5x and dividing by 2. Do not forget that when you divide by 2, you divide this by 2, and this by 2, and this by 2. You divide everything by 2. Your slope should be negative 5 over 2. Your y-intercept should be 5. It goes through here, goes down 5 over 2, and it should be the same graph as 37. They're the same equation.